All right. Hello, everyone. Welcome. This is Aikotam from Technologics Inc., Marketing Department. I want to thank everybody for investing their time as we look for a great hour. This is our first webinar. I'm with the technical engineers of NX Solution here in the Philippines. For 45 minutes, we'll be presenting the essentials for excellence in mold, tool, and die industry. And after that, we'll be having a Q&A. So for those who have any questions, you may leave a message on chat box, then we'll capture it later. So before we start, let me just give you a brief introduction of our company. Okay. Technologics established in 2003, and we're currently Tier 1 partner of Siemens PLM software as we locally provide solutions for product development, product data management, including simulation for product analysis. We also conduct local workshops, seminars, and trainings. So if you'd like to know more about our solution or the available solution here in the Philippines, you may visit our website, technologic-ph.com, or you may email us at marketing@technologics-ph.com. Now, for our presentation, again, this is Aiko Tam, your host from the Marketing Department. Our first presenter will present about CAD, Mr. Noriel De Leon, a licensed electronic engineer with 7 years application engineer for NX CAD, knowledgeable also on ECAD and PCB layout application. He is also trained in mold design and progressive die application. Our second presenter, later, Noriel will turn over the screen to Mr. Ramos, our second presenter, to present the manufacturing side. So Ramos is a licensed mechanical engineer with 6 years as a design engineer and CAM programmer from a Japanese engineering firm, with 5 years application engineer for CAD and CAM, experience for product design and styling, who won a global CAD design contest and won from CAD. Okay, so now without further ado, I'll pass the screen to our presenter, starting with Mr. Noriel.
Hello everyone. So thank you, Miss Aiko. So again, welcome to our first ever webinar. So thank you also for joining us today to go over a comprehensive solution presented by Siemens PLM software for the tooling industry that can accelerate production through integrated, innovative, and proven technology. So over the last few decades, there are changes happening to the mold, tool, and die industry. As per the IMF World Economic Outlook, the Western European economies will grow at a slower rate with higher growth in the United States and continue to grow in Asia, including, of course, the Philippines. So adaptability became one of the key elements for companies to stay competitive, deliver complex jobs, and satisfy customers' expectations. So, the introduction of multitask machine tools to increase productivity and reduce turnaround times is one of the most dominant trends in the industry. But it has added more complexity to the process. With competition, producing high-quality tools at a low-cost rate, price and time have become the critical success factors in the tooling industry. Then questions such as, how can I deliver high-quality molds to my customers faster than my competitions? And how can I help my customers design product right the first time are quite common. Ultimately, the tooling industry is striving to pull together the multiple pieces of the tooling design process, integrate and manage it with their product development processes. So in today's webinar, I will cover the challenges faced by tool design and manufacturing industry, and how the solutions from Siemens address these challenges through advanced automation, process simulation, and integrated technology to accelerate the process, reduce waste and cost, and improve quality. So on the latter part, you will see how it can help improve our processes by showcasing these features on the solutions presented. So let me start. One of the obstacles that tooling companies face is poor communication with the OEM. So OEM is the original equipment manufacturers, want more involvements on the collaborations. So to counter this, we have a diagram which we call is the early supplier involvement, which is becoming quite common in the tooling companies. So it is a process that brings you and your supplier together early in the product development, with the shared goal of getting your products to market as quickly as possible with the highest quality. So if you've noticed, the first step of the process is for mold manufacturers to receive data. So they referred to this as the database from their customer. So this database typically includes STEP or IGES file. Sometimes the data arrives in a native CAD format and must be translated. Next is that once this data is obtained, it is analyzed for data quality and repaired if necessary. Moldability, so that is checking for correct drop angles, and part properties. So these are volume, surface area, and wall thickness, which all affect the potential cost and quality of the resulting molded part. So when issues are identified, of course they are corrected. Now, if the database is altered in any way, it is important for the mold manufacturers to review the design changes with the customer. After the customer has signed off on the design and any changes done, then we go to the other system. So there are another development in the industry which is coming into change. Then we talk about 3D printing. So PolyJet 3D printing has made it feasible to quickly create custom injection molds that produce low volumes of parts in the final production of this plastic. So as you can see on the image from the left side, PolyJet 3D printed molds are not production molds, but during the design and testing phase, they offer a clear advantage over conventional injection molding. So product designers and manufacturers can use these molds to perform thorough functional testing without worrying about cost-prohibitive tooling. So this can also reduce costly, time-consuming mold corrections, increase product innovation, and speed up product development. Of course, direct metal laser sintering, or the DMLS, is a key technology used to print tool cores, often called as mold inserts, for injection molding processes. So this process lets engineers optimize the design of cooling channels, wherein cooling channels can be printed to any shape and closer to the part than subtractive methods can occur for the CNC machining. So the sample of this is what. So the resulting formal cooling channels save time, cut waste, improve quality during the production of injected molded parts. So now, given the new landscape, just about every surviving mold die shop, new changes had to be made. So performance rating was shown here. So the best in class quickly moved to increase design efficiency. As a result, they reduced their job turnaround times. Then adaptive strategies to offer value-added services, and niche-to-market focus to differentiate them so they didn't have to compete on price only. So as a result of embracing the trends, big performance gaps exist between best-in-class and laggard shops, or the mold and die shops. So as you can see, the best-in-class quote accurately and on time on a 96% or better average. Next is that they also deliver the tooling on time with high quality on a 99% or better average. So the question is that how did they achieve this? So as you can see, we have key enablers or technology enablers wherein adapting the right technology along with a combination of people and process is, we can say, this is the key. So these businesses use integrated CAD/CAM CAE software along with design automation to eliminate manual and mundane tasks so that they can respond faster. They also use simulation and design for manufacturability to optimize the manufacturability of the part and tooling. So on the last part, they also implemented PDM, PLM systems to manage tool designs and find the right data quickly. But then there are some challenges. So we often hear that there are discrepancies, big gaps between the product design. So what happens on the shop floor and what is really defined in the system. So another common issue is information silos and problems such as manufacturing not involved in design discussions early enough. The process starts with input from the part design, usually a 3D model created using CAD software. So on the left side, we refer this as product engineering. So this data is used as input for manufacturing engineering. So at this stage, machining and inspection methods for the part are defined using CAM, CMM, or other related software. So eventually, on the last side, this data is used in production to set up and drive manufacturing equipment on the shop floor. So take a closer look. So bridging the gaps between these processes is the key challenge for manufacturers. So let's talk about, it would be a big benefit if companies could bring all engineering and manufacturing information into one place. So everyone can have a clear understanding about how the process is expected to perform and how it is actually performing. So the effectiveness of the sequence can significantly impact the value you realize from your manufacturing equipment. Now, let me start with the discussion with product engineering. So let's check some of the challenges identified and what I have mentioned on the ESI, or the early supplier involvement. So mold designers are usually creating mold geometry from existing part geometry. So this part geometry can come from many sources, so including customers and suppliers, and often if it's not in the same data format the mold designer is using. So imagine this, that it causes translation issues that make the design take longer and increase the chances for errors. So turnaround time is also a key competitive advantage for mold designers. So having to recreate geometry from scratch increases turnaround time. Of course, you need to redesign, and then which makes for higher costs and, of course, sometimes unhappy customers. Of course, fast turnaround time doesn't mean much if it doesn't fit in right. So being able to make sure it's right quickly not only increases quality, it increases confidence. So on the right side, you will see the Siemens solution. So with the industry's broadest suite of integrated and proven software for manufacturing engineering, Siemens provides you with unique and powerful advantages. So NX is the industry leader in not just reading data from multiple CAD sources, but being able to work with and modify it. Tools such as synchronous technology give NX unmatched ability to work with multi-CAD data. Of course, automation and reuse are the keys to speed up turnaround time in mold design. The NX Reuse Library enables the user to take advantage of existing proven designs. Then we have NX Mold Wizards automates the mold design process by making it easier to follow with a step-by-step approach. Under this, early validation is another strength of NX. We have DFM Pro and EasyFill Analysis, which are among the tools NX mold designers can use to verify their design. And of course, make sure the job is done right the first time. So let me discuss this one by one. So let's have a closer look on how NX enables you to view and work with multi-CAD data from virtually of any source. So as you can see, there are two key areas that we will focus for multi-CAD. On the left side, NX has the ability to read and modify data from multiple CAD systems. And of course, add intelligence to that data. So as you can see, along with the major CAD packages, neutral formats such as JT, STEP, iJets, and other can be opened directly. So if you have these CAD data, there's a very good chance that NX can open and read it. So after the first challenge, of course, we have the second one. So on the right side, so once the data has been read into NX, it can be modified as needed. So with the use of synchronous technology. So eliminating the need for slow, error-prone translation. Again, synchronous technology in NX offers fast and intuitive design creation and modification. You can easily modify a part even if you don't know how it was originally created. And the modification process is amazingly fast and intuitive. The next one is, let's discuss of how NX can help to automate the mold design process while reusing, of course, existing designs. So like what I've mentioned, NX Mold Wizard embeds tooling expertise into NX. So there are enabling you to create molds based on the product model with full associativity between the two. On the middle, using the mold-based and standard part catalogs, along with integrated reuse library, you can easily take advantage of existing proven designs. Generating fully detailed drawings for production is also a high repetitive and time-consuming task. So with NX Mold Wizard, it automates this process. So producing drawings for inspection, shop floor assembly, NC and other uses can be done by just a click of a mouse. So as you can see, these are the major capabilities or key features of NX Mold Wizard. So it optimizes the mold design process, delivering levels of productivity that dramatically outperform traditional CAD software. So NX Mold Wizard is a built-in NX application wherein the industry's most powerful product development system. So as a result, the tools for working with part geometry, creating parting surfaces, and enabling automatic updates are among the most robust available. Then, less capable system may handle basic parts and molds, but NX Mold Wizards can tackle the most demanding tasks. So let me mention some of these. So we have the comprehensive data import with translator, manufacturability for checking of molded parts, and then the full integration of validation and analysis. So this one is a testimonial coming from a company, the Sri Devi Tool company, wherein they've said that due to some design issues with the vendor, they've decided to bring the design work in-house and implement NX because of its advanced functionality for mold design. Then it has the user-friendliness with the good and intuitive interface and ease of modifying existing design and parametric modeling. So the result, it gives them an immense benefit, like mold designs completed half the time, mold development cost savings of more than 40%, and then lastly, productivity gains of more than 50%. So we now go to the last part of my presentation. So getting the job done right the first time depends on early validation of your designs. So it gives confidence not just on the designers and then the suppliers, but also for the customers. Of course, NX has various tools for ensuring mold and part quality, including the ability to analyze draft, shrinkage, parting lines, cooling, and many others. In addition, DFM Pro, another fully integrated tool in NX, doesn't just check to see if a part is manufacturable. It suggests corrective action if it is not. Of course, secondly, the mold flow simulation is also integrated into NX. Though it is powered by Moldix 3D, it allows you to check for mold flow issues for any expensive parts have been made. Sometimes, poor molded part designs can negatively impact the quality and cost of the tool. So NX Mold Design Validation improves molded part quality. It helps identify and eliminate the various types of issues highlighted on this slide. So as you can see on the left side, so these are the issues being seen or changed from the validation stage. So it includes tool for analyzing data quality, reporting data quality issues, and sometimes suggests how to eliminate this issue. So NX model tools can be identified to heal or repair inappropriate data. So DFM Pro is another fully integrated design for manufacturability and assembly solution with NX. So it helps identify design areas that are difficult, expensive, or impossible to manufacture and suggest corrective action. So now, on this slide, there are also some quality of the tools which can be validated using various tools provided in NX Mold Design. So for example, avoid blowouts by using NX Strength Wizard, to increase the life of the mold by detecting and removing sharp corners on the parts. So through integration, in some cases, NX CAE can be used for performing an advanced cooling analysis and motion simulation. So as you can see on the video, you can check for interference or collision related issues during simulation. So again, that sums up my part on this webinar. Next is we'll discuss the details of solution with manufacturing engineering, which will be provided by my colleague here, Engineer Remus Pasis.
Okay, good afternoon everyone. Okay, let's go on the manufacturing side of NX. The mold design data from the project engineering is used as an input for the manufacturing engineering in the tool room. Here, the machining process and inspection method to manufacture the mold are defined using CAM, CMM, and related software. The output in the form of G-codes, inspection programs, tooling data, and work instructions is generated and sent to the shop floor. On the production shop floor, this data is used to set up and drive manufacturing equipment to machine all the mold components. So, what are some typical challenges that mold and die manufacturers face today? Inefficient process can affect production in many ways. For example, when manufacturing companies try to fit separate software applications together, it often results in a process that requires multiple data conversions. To be competitive in today's environment, manufacturers need to increase their throughput. The manufacturing software can affect your productivity. For example, when the CAM software doesn't provide a complete set of CNC programming capabilities, or when it lacks application-specific functionalities, it can reduce your efficiency. And finally, reliability in the manufacturing process ensures consistent production quality. To be competitive, mold manufacturers need to synchronize the entire manufacturing process, maximize the machining efficiency, and hit the production target. Let's look on how Siemens can help you address these challenges. To run more an efficient and nimble business, all the manufacturing activities need to be synchronized. Siemens PLM provides an integrated manufacturing software solution to support the entire manufacturing process, from CAD, CAM, all the way to the CNC controller on the shop floor. A driven process lets you collaborate and work concurrently. It all starts in the part model that needs to be manufactured. You just saw the advanced tool that lets you create a mold assembly from the part model, which is the Real de Leon. Well, now, let's see how this part model can drive the entire manufacturing process to machine the mold assembly. The mold design is the input to the manufacturing process. The upper half of the diagram describes the process to define the process to machine the mold. Using the CAD design tools, you can quickly prepare the mold for machining and also design the pictures. The next step is to define the machining for the mold by using the CNC programming capabilities in NXCAM. It lets you achieve the high-speed machining and high-quality machine surface. To ensure first-time machining, the CNC program can be verified in NX by using the G-code-driven simulation. A complete set of shop documents can be easily generated. You can transfer CNC programs, tool lists, setup sheets, and drawings directly to the machine tools on the shop floor. While you were defining the manufacturing process for the mold, your team can work on the electrode machining using the same unified NX system. And working on the same data, which is shown in the lower half of the diagram, they can design, prepare, and program electrodes that are part of the mold assembly. Besides CNC programs, NX lets you create an inspection path which drive CMM machines. The output of the electrode programming steps includes CNC and inspection programs is transferred to the production to drive the manufacturing equipment. The molder-driven process ensures associativity to the supply design data, concurrent workflow, and accuracy and reliability. Many mold manufacturers around the world use this integrated platform to maximize their overall productivity. A good example is the Minco tool and mold is one of them. Minco is a major plastic injection mold manufacturer in the US with more than 50 years of experience. To capture a niche in the market for manufacturing complex shaped parts, they use NX Mold and NX Cam. The molder-driven process in NX by the master molder ensures easy and accurate propagation of design changes from product to NC programming. The integrated solution for mold design and manufacturing is a key to Minco's success. They can achieve high-quality manufacturing by maintaining accuracy in the product design, tool design, and CAM programming. To stay competitive, Minco leveraged the advanced capabilities and the integrated platform of NX. NXCAM delivers real difference through key capabilities, such as its advanced programming, integrated post-processing and simulation functionality. The optimized CNC programs and the complete shop document generated by NXCAM can maximize the productivity of your machine tools. NXCAM provides a wide range of advanced functionality, from a simple CNC programming to complex multi-axis machining, enabling you to program all the parts of the mold assembly by using one system. The intelligent tool path ensures efficient machining and increased productivity. For example, you can quickly remove material on your mold used with the high-speed machining capabilities, or NXCAM lets you automatically tilt the tool so you can use the right tool to improve the surface finish. Advanced feature-based machining provides extra value in programming automation. The system automatically identifies machining features and it applies machining operations. This capability is particularly useful for programming mold plates that can have many features, such as pockets, slots, and complex holes. With feature-based machining, you can reduce programming time by as much as 90%. Machining data library and process templates enable you to apply proven data and processes. This knowledge-driven programming can improve your productivity and ensures repeatability. NXCAM provides an advanced capabilities optimized for mold and die manufacturing. High-speed machining for hard material can significantly reduce machining cycles. For example, the high-speed wrapping in NX maintains high metal removal rates while managing tool loads. Superior surface finish can achieve by using the available smooth flowing cutting strategies that can follow critical contours of a part, resulting in fine finish and high feed rates. Having a full control of the machining process enables you manufacturers to reduce risk and improve quality. The cut region control provides a new level of control and ease of use in planning machining strategies for complex molds. You can preview, change, and reorder the regions and the associated operations before generating for toolpath. To increase the throughput, successful mold shops use multi-axis machining, include 5-axis machining. It lets manufacturers maximize the numbers of setups, which is significantly time savings, increase tool life, and improve surface finish. The close connection between engineering and planning enables the manufacturing team to achieve the right control of the manufacturing process. And Siemens offers advanced technology that can connect your engineering and shop floor teams. Complete manufacturing documentation, including programs for your specific equipment, tool list, setup sheet, and drawings are essential for machining right for the first time. With NX, you can not only generate the complete work package, but you can also validate CNC and inspection programs so that you can minimize testing on the shop floor and you can speed up wrap-up time. You can deliver manufacturing the planning data directly to the machine tools and CMM equipment by using Siemens Direct Numerical Control, which is the NC solutions. Extending PLM to the shop floor opens a new possibilities. For example, elimination of duplicate data and better workflow management from design through to manufacturing. As the shop floor team uses this data provided by the engineering to run the production equipment, it's critical that the latest production data is sent back to the engineering. For example, quality inspection results from CMM machines can be collected and sent from production back to the engineering for analysis in NX. This solution ensures that the entire manufacturing team uses consistent and up-to-date information that enables a more efficient manufacturing process. One key advantage of having an integrated solution is that it enables efficient design change management. When a new revision of the product model is introduced, the design changes easily propagate throughout the process. So let's take a look on a short demo of how our integrated CAD/CAM CNC solution to see how it helps mold manufacturers.
It all starts at the tool designer's desk, who struggles with the question, can this part be successfully molded? The primary concern is that the part is properly drafted. NX Mold Wizard's validation tools analyzes the part and automatically provides the designer with information about draft angles, undercuts, etc. Apart from mold design validation, you can also do material flow analysis. NX EasyFill Analysis, powered by Moldex 3D, is an integrated mold flow simulation tool for designers to analyze plastic part design for moldability during the early stage of the product development process. Once the part has been validated by the tool designer, next step would be to create the mold tool design. NX Mold Wizard has advanced automated tools for creating parting lines and surfaces. Based on the draw direction and different regions defined, NX Mold Wizard will automatically create optimal parting lines. These parting lines can be easily modified if needed. NX Mold Wizard will guide you through the creation of parting surfaces. Along the way, it will recommend surface types based on the geometry conditions. After defining the parting surfaces, you are ready to split the core and cavity. With a single click in NX Mold Wizard, the core cavity extraction can be executed automatically. Next, the 3D mold base can be created quickly using the library based on industry standards such as Hasco, DME, etc. Using the Moldex 3D flow inside NX, you can simulate the entire filling process of injection molding and post-process the results to understand what and where the problems happen in cavity filling phase so as to further optimize the designs. You can also define realistic runner and gates for your mold design. Using NX Mold Wizard, you can simulate the mold assembly to check how the tool would work. You can dynamically check for interference and fix the defects in the design phase itself. Generating fully detailed drawings for production is a highly repetitive and time-consuming task. NX Mold Wizard automates this process. Producing drawings for inspection, shop floor assembly, and other uses can be done by just a click of the mouse. Switching over to CAM, you can quickly prepare the model for NC programming, such as patching complex openings by using the advanced CAD capabilities. NXCAM provides a customizable machining database that enables you to manage and reuse proven data to toolpath operations. Optimized roughing methods maximize the material removal rate without overloading the tool. The smooth toolpaths are ideal for high-speed cutting of hard material. Fully automated rest milling powered by the in-process workpiece removes uncut material from previous operations and eliminates air cutting. NXCAM lets you automatically convert 3-axis to 5-axis toolpath, giving you the ability to reach deep cavities with short tools, thus reducing chatter and extending tool life. Advanced finishing techniques that follow the natural shape of the mold can deliver superior surface finish quality. Helical toolpaths can be used to efficiently machine the holes in this mold. The G-code driven machine tool simulation displays the motion driven from the NC program and send error-free programs to the shop floor. The post-processor system is highly connected to the core CAM system. You can easily generate the required NC code for almost any type of machine tool and controller configuration. You can create complete sets of shop documents such as tool list and setup sheets, which are essential to drive an efficient manufacturing process on the shop floor.
Okay, you just saw a video showing the integration of CAD from product design, mold design, up to the manufacturing or the CAM. Now, another example is the Miplex Mold Incorporated. Miplex Mold is a manufacturer of mold with more than 25 years of experience. They chose NX because of the integrated CAD and CAM solution. With NX, mold design and the toolpath creation takes place concurrently. While the tool designer is finishing the mold, the CNC programmer can start the programming work in NX CAM. This is possible in spite of the fact that many design changes are still coming in from the customer and because of how easily the NX geometry can be changed. The efficient manufacturing process driven by NX enables Miplex Mold competitive. They reduce the overall mold development cycle by 35%, and the high speed and precise toolpath can be updated 50% faster after design changes. To conclude, this chart summarizes the breadth of our solution for design and the manufacturing process. As in this presentation, the path from the initial CAD model to the production phase is tightly integrated NX, leading to significant productivity gains across the entire tool development and the manufacturing process. Okay, thank you for listening. I will bring back the floor to Aiko.
All right. Hello. Okay. All right. Thank you, Nariel and Ramos. Okay, the presentation showed you how NX solution help mold manufacturers. The advantage of having integrated solutions such as NX enables efficient design and fast and match manufacturing. Now we're on our Q&A part of our webinar. So do you have any questions? Please chat it on the chat box. Okay, don't be shy. All right. I don't see any questions here. So if you have no further questions, we shall end this webinar. Should you need to clarify, feel free to email us or follow us on our Facebook, social channels, Twitter, YouTube, and LinkedIn. Okay, let me just check. Okay, no. Okay, no questions. So I will just share the link. I would like to request everyone to answer a short survey. It's shared at the chat box. Please click the link. Okay, we do hope that this session gain your awareness on the available solution in the industry, and each of you will stay competitive. Please also take advantage of sharing this information on your colleagues. We'll be sending you to ask for your feedback on this webinar, as shared on the chat box. And this link is recorded and we will share it to you as well. So on behalf of Technologics Inc., we would like to thank you for attending this webinar. Thank you and goodbye.